Welcome to the class 11 students. Students, this is the second video of the numerical problems of the chapter 4 of your NCERT book, Motion in a Plane. First video you people have probably seen. Students, in this video we will discuss the numerical problems based on the concept of relative velocity. Before starting the video, please like, share and subscribe our channel. Students, this is Raj Deepak and Javis Piani. Let us start the video. Students, before starting the numerical problems, let me explain for you, let me recapitulate for you the concept of relative velocity. There are mainly four types popular problems solved in relative velocity concept, that are river swimmer problem, this one river swimmer problem, second one is boat river problem, and third one is aeroplane wind or air problem. Third one is aeroplane wind or air problem, and fourth one is man and umbrella problem. So these are the four types problem, students, that we will solve with the help of concept of relative velocity. Students, let me recapitulate relative velocity concept for you, then thereafter I will go to the numerical problems, and this explanation will help you to understand clearly the numerical problems based on the concept of relative velocity. Students, let us start. See here, suppose this is a pond, means तालाब. ये एक pond है, and the water is filled in it, and water is still. So one man is standing over here, this is the man, and want to cross this pond, and the width of this pond is D, and this is the swimmer want to cross this pond. So students, he will jump in the pond and will swim with velocity Vs, velocity of swimmer, and it will, suppose this is the point A, it will just reach to the point B, just opposite to the point A, without any drift, because water is still. So he will jump and will reach here. So what will be the time taken by him to cross the pond? We know that distance is equal to velocity into time, Vs into t. So that will be d upon Vs into t. So this will be the time taken by the man to cross the river. Now come to the other concept. This thing you will have to keep in your mind. पानी अभी शांत है. The water of the pond is not flowing anywhere, so water is still. So in still water the velocity of the man is Vs. I mean to say velocity of the swimmer is Vs. So he will reach d upon Vs time to the bank B. Okay, see here. Oh, pen is not good. See here, this is the, suppose this is the river and water is flowing in it with velocity Vr. This is the velocity of river, and now again one man is standing over here and want to cross this river, and he jumped. This is the point A. At point A he jumped into the river. So students, will it reach to the point B just opposite to the point A, or he will drift and will reach at the point C? What do you think? Students, he will drift and will reach the point C instead of reaching point B, because water is not still in this case. So here, student, this is the velocity of swimmer. This is Vs. So velocity of swimmer is just vertical direction and velocity of river is just horizontal direction. So I want to make the free body diagram of this person. This is the velocity of the swimmer and this is the velocity of the river. So simultaneously students, two velocities are acting on the swimmer. One is drifting him from B to C and one is helping him to reach the other bank. Student, vertical motion he will do with this velocity and horizontal motion he will do with this velocity. Do you understand? I mean to say, with Vs velocity he will travel the distance AB and with velocity Vr he will travel the distance BC. This thing you will have to keep in your mind. Student, now see. Suppose one other man is standing outside the pond. He is watching this man. So what he will observe? This is the ground frame. And suppose one man is sitting in a boat. This man is sitting in the boat and is also watching him. Then what he will observe? These are the two frame of reference, ground frame of reference and river frame of reference for this person, because he is flowing with the velocity of a river. This boat is flowing with the velocity of river. Okay students, now try to understand the beauty of the concept of relative velocity. The students, see here, when he will see, means the person who is standing on the ground will see the man, then he will see that two velocities are acting on him and he is going to the direction of the resultant velocity of these two velocities towards this direction. Good. This is the velocity of the man in his frame of reference. See here students, see, this was the free body diagram. This was the swimmer and this was the velocity of river and this was the velocity of swimmer. So if in his frame of reference, boat must have to be stationary. Not understand? Okay. See the simple case of one dimension motion. Over here you take very simple case. Suppose this man, this man, actually my drawing is not good. This man is going towards this direction with velocity Va, and another man, Vb, means this man, whatever apparatus it is going to this direction with velocity Vb. So student, if I want to ask a question to you that what will be the velocity of with respect to velocity of B, so what we will have to do? We will have to make the velocity of B, this person B, 0, and from there I will conclude the velocity of this person A. So what will be? Va minus Vb. Okay, this is the relative velocity of A with respect to B. Good? Not understand? If not understand, then go through the first chapter. See here, in this case, river is flowing through this direction and the swimmer is going to this direction. See here, if I want to observe all the things with the boat frame of reference, then boat velocity must have to be 0. So for that, this line, this will be the resultant velocity, means Vs minus Vr. So in his frame of reference, the swimmer will go in this direction. In this direction swimmer will go. So students, we always solve the problem in the ground frame of reference. Okay, not in the river frame of reference. This thing you will have to keep in your mind. Okay, now let us start the numerical problems, and while solving the numerical problem you will better understand the concept of relative velocity. Let us enjoy it. Now students, let us start the questions. See here student, the first question. A river 1 kilometer wide flowing at 3 kilometer per hour. A swimmer whose velocity in still water is 4 kilometer per hour can swim only for 15 minutes. In what direction should he strike out in order to reach the other bank? What is the total distance covered? Students, in this question, what the question is asking to us. See, a river is there whose width is 1 kilometer and is flowing with velocity 3 kilometer per hour, and a swimmer whose speed in still water is 4 kilometer per hour and that can swim only 15 minutes. Then you have to tell in what direction the swimmer will strike in order to reach the other bank, and total distance traveled by the swimmer. These things you will have to tell. See here, this is the river. This is the river. These are the banks actually, and this is flowing. The river is flowing. The velocity of the river is VR, means 3 kilometer per hour. This is the velocity of the river. Now width of the river is given to us. This is what? 1 kilometer. This is the width of the river. And now student, one person is here. This is the swimmer, S. Want to cross this river. His speed in the still water. Suppose this is the point A and this is the point B just opposite to point A, means just in front of point A, B is there. Then he jump and his velocity along the vertical direction will be Vs. So student, when he will jump into the river, the two velocities will act on him simultaneously. See, in this diagram, this is free body diagram actually. Here V are the velocity, Vs is the velocity of the swimmer. Okay, so I already told you student, we always solve the problems from the ground frame of reference unless stated otherwise. I mean to say, जब तक ना कहा जाए तब तक ग्राउंड फ्रेम ऑफ रेफरेंस से प्रॉब्लम को सॉल्व कीजिए. दैट विल बी इजी. See, and one person is here. This means the person is watching this man. So what he will observe, that this man is going towards this direction that we had discussed earlier. Means the man's velocity, means swimmer's velocity, will be along the direction of resultant of these two velocities. Means he will not exactly reach to the point B, he will reach to the point C. Okay, so he will make angle. So this direction we will have to tell. This angle theta we will have to tell. Students, the direction of velocity V will be along AC. This will be the direction of velocity. So students, see here, if the angle between two vectors is 90 degree, then what will be the resultant vector? See students, you have been taught that the resultant of two vectors are square is equal to, if the first vector is a, then a square, then second vector is b, then b square plus 2ab cos theta. If suppose this is the vector a, this is the vector b, so the resultant of these two vectors according to the parallelograms law of vector addition you have been taught, this will be r if this angle is theta. Okay, now students, in this case this angle is what, pi by 2 means 90 degrees, so the resultant will be what, r square is equal to a square plus b square. In the same way we will get the resultant v is equal to root vr square plus vs square. So that is given to us, that is given to us. And what is that? See, this will be root 3 square plus 4 square means 9 plus 16 means 25, that is 5 kilometer per hour. So the velocity of the swimmer is 5 kilometer per hour. Now what we will have to tell? We will have to tell theta. So for that, see here, I am again redrawing this diagram. See here students, this is VR, velocity of river, this is velocity of swimmer, and now we are we are applying the parallelograms law of vector addition. See here students, this is parallel to Vs, so this will be Vs, and this angle we will have to tell, this is Vr, so tan theta is equal to nothing but Vs by Vr, so that will be Vs is what, 4 by 3, tan theta is equal to 4 by 3, so theta is equal to tan inverse 4 by 3. Students, one triangle you will have to keep in your mind, that is what? See, this is the triangle, suppose ABC. If this angle is 37 degree, then this will be 3, this will be 4, and this will be 5. Obviously if this is 90 degree, then this will be what, 53 degree. The sum of all angles of a triangle is what, 180 degree. So in this base, this is 37 degree, this is 53 degree, and this is pi by 2 means 90 degree. So sum all the angles, then you will get 180 degree. So students, what will be the value of tan 53? See here, perpendicular upon base means 4 by 3, so the angle is equal to 53 degree. So the swimmer will move 53 degree angle with the ground frame of reference, or with the bank of the river. Okay, now next, what the question is asking, what is the total distance covered? Means this part I am going to solve now. What is the total distance covered? So see here students, one thing is given to us, means what is given to us, 15 minutes. The swimmer can swim only 15 minutes. So velocity is given to us, time is given to us, then can we tell the distance traveled? Yes, why not? We know that. Velocity is equal to, distance is equal to velocity into time. So distance covered we will have to tell. So what is the velocity? 5 km per hour. And time is given to us 15 minutes. So 15 minutes we can convert into the hours. So that will be what? Let us minutes. Okay. So see, 5 km per hour. For converting minute into hour, what we will have to do? We will have to divide it by 60. Means 4 means 5 by 4 means 1.25 kilometer this much distance the swimmer will travel. Okay, students. Now students, come to the next question. See here students, the question number 2. A boatman row with a speed of 10 km per hour in still water. If the river flows steady at 5 km per hour, in which direction should the boatman row in order to reach a point on the other bank, directly opposite to the point from where he started? The width of the river is 2 km. Now students, what he is asking exactly, let me tell you. See, this is the river. Okay, the width of the river, and this is flowing. The river is flowing. What is the speed of the flow of the river? That is 5 km per hour. Okay, and width of the river is 2 km. 2 km is the width of the river. Now a person, the question is asking, a boatman row with a speed of 10 km per hour, means a boatman is there. This is the boat. This is the boat, and this boatman can row the boat in still water, means from A to B. The velocity of boat towards this direction will be what is given to us, that is 10 km per hour. Now students, see here again, the question is asking that in which angle the boatman row his boat in order to reach exactly at point B. See, if the man will row directly, then he will reach at the point somewhere here at point C. Now in order to reach at point B, the boatman should row his boat towards this direction. Towards this direction means, see, now again I am redrawing the diagram. This is the boat, this is the river, and it is flowing. Now this is the point A and this is the point B. In order to reach point B, the boatman will row with the angle theta from vertical in order to reach directly at point B. Okay students, so what is his speed? Here his speed is 10 km per hour, and the speed of river is in this direction is 5 km per hour. So students, see here, we will resolve this velocity into two components. Horizontal component, that will be what, 10 km per hour sin theta, and this will be 10 km per hour cos theta. Student, in order to reach at point B, this component of the velocity should be cancelled with this component. Then the resultant effect of the horizontal velocities will cancel out and the boatman will reach at the point B. You try to think. If these components were not equal, then what will happen students? Suppose this is more than that of 5 km per hour, then the boatman will row his boat towards this direction and will reach somewhere here in this point. If this velocity is greater, then he will reach towards this point somewhere here towards the left side of the B. If this is greater, If this is greater, then it will reach at the towards the right side of the B. In order to reach at point B exactly opposite to point A, the horizontal components should be cancelled to each other. Means this is the primary condition. So tan sin theta will be equal to 5. I have equated both of them. Then sin theta, kilometer per hour and kilometer per hour will cancel each other. This is 1 by 2. So theta is equal to what? Theta will be what? What is the value of sin? What is the value of sin 1 by 2? That will be pi by 6, means 30 degree. So this angle is what? 30 degree. At the angle of 30 degree, he will row his boat in order to reach the point B. Okay, first part we did. Only one part was there, so we have completed. At the angle 30 degree, he will reach at the point B. Now students, how much angle the boatman will make from the horizontal? I mean to say, what will be this angle? If this angle is 30 degree and this angle is 90 degree, this angle is 90 degree. So what will be this angle? Means the boatman will make angle 120 degree with the horizontal. Means the answer will be 120 degree. He will row his boat by making angle 120 degree from the direction of the flow of the river. Then he will reach exactly at point B. Now student, come to the man and umbrella problem. See here students, the question number 3. A man is going due east with velocity of 3 km per hour. Rain falls vertically downwards with a speed of 10 km per hour. Find the angle at which he should hold his umbrella so as to save himself from rain. Students, you also observed that when you ride your cycle, you feel that the rain is coming towards your face. Have you observed the same thing? Suppose this is the person who is riding the cycle and moving towards this direction with velocity Vm, velocity of man, and rain is falling vertically downwards. Students, he will bend his umbrella towards this direction so as to save himself from rain, not vertically upward. Or when he will stop just vertically upward, he will hold the umbrella to save himself. But as soon as he will start moving, he will have to bend his umbrella with a certain angle so as to save himself from the rain. You also might have observed this thing. So let us discuss why this thing happens with the help of this question. Students, one person is going towards east. So let us draw first the directions. Students, this is north, this is south, this is east, and this one is the west. So this person is going towards east and rain is falling vertically downwards. Let us draw a free body diagram. See here, this is the velocity of rain and this is the velocity of man. So students, what will be foretelling in which direction he should hold his umbrella for saving himself? What we will have to do? We will have to find the relative velocity of rain with respect to man. Means in the man frame of reference, what will be the velocity of rain, that we will find. So for getting that, we will have to draw a line. this line will represent the difference of these two velocities. So this will be Vr minus Vm, means a relative velocity of rain with respect to man. These are the vectors. Now students, in the person eyes, in the man's eye, the direction of velocity of rain would be this, but in actual it is this. Okay, for saving himself from the rain, he will have to bend his umbrella to this angle, theta. So this theta we will have to calculate. For that we just apply tan theta. Tan theta is equal to what? Perpendicular upon base, Vm by Vr. Students, Vm is given to us. See here, this thing we are doing over here, tan theta. Vm is what? Vm is 3 by 10. So theta is equal to tan inverse 3 by 10. This will be the direction of holding an umbrella, so the person save himself from the rain. Okay students, this thing we can do with the other diagram also. Let me tell you. See, suppose these are the coordinate axes. This is the x-axis and this one is the y-axis. This is vertically upward y-axis and this is the horizontal direction. So this is the direction of east, but this is not the direction of north, because this is the direction of vertically upward. So student, the rain will fall in this direction, Vr. A man will go in this direction, Vm. So getting the difference of these two vectors, what we will have to do? We will have to just make it opposite, Vm. So it will be minus Vm. So these are the two vectors. What will be the resultant? So the resultant will be this, according to the parallelogram's law of vector addition. So student, this angle we will have to tell. So for telling this, suppose this is Vrm. So what will be Vrm exactly? Vrm will be, students, you have been taught r square is equal to a square plus b square plus 2ab cos theta. This formula you have read. The angle between these two is pi by 2. So the formula will be r square is equal to a square plus b square. Same formula you people apply here and you will get Vrm. In this question Vrm is not asking, that's why I am not going to find it. But student, we can discuss the formula over here. See, Vrm is equal to root Vr square plus minus Vm square. This you put and you will get Vrm. Now students, let us discuss one more question of man and umbrella problem. See here students, the question: a boy is moving with a velocity of 3 km per hour along east and the rain is falling vertically with a velocity of 4 km per hour. Calculate the velocity of rain with respect to the boy. Students, draw here first directions. This is north, this is south, this is east, and this one is the west. Okay students, in this question it is given to us the velocity of boy is 3 km and he is moving along east direction. So it is 3 km per hour along east and the rain is vertically falling downwards with the velocity 4 km per r. Okay, clear picture. Let me draw, student. But vectorially I want to draw this picture. Students, see here, this is the I cap, direction of I cap, this is the direction of j cap. Okay, and similarly this is the direction of minus j cap. So here you see, this is nothing but, again I am drawing, see, this is 3i cap and this is minus 4j cap. Okay, these two vectors are here. Now students, question is asking, calculate the velocity of rain with respect to the boy. See here, let me draw another diagram. The velocity of boy was Vb, velocity of rain was Vr. So what we will have to get? We will have to get relative velocity of rain with respect to the boy. For that we will have to draw this line. This line will represent the velocity of rain with respect to the boy, that is Vr minus Vb. So in the boy's frame of reference, the direction of rain would be this, not vertically downwards. Okay students, so this vector we will have to tell. So what will be this vector? Vrb is nothing but Vr. What is Vr? Velocity of rain, that is 4j cap, minus velocity of boy 3i cap. So this is the velocity of rain with respect to the boy. Now what will be the magnitude of this velocity, students? Simple, Vrb you will have to get mod. So it will be what? Root the square of coefficient of I plus the square of coefficient of j. So minus 3 square plus minus 4 square. So it will be nothing but 9 plus 16, that will be root 25, and here you will get 5 km per hour. So the velocity of rain with respect to the boy is 5 km per hour. We have solved this question. Students, thank you for watching our channel. If any doubt or any query is there, please ask in the comment section. With a new video I will soon present in front of you. In that video we will discuss the projectile motion and will do the numerical problems of the projectile motions and some problems of the cross and dot products. Thank you students.